So let's take this problem. A reinforced concrete slab 150 mm thick is reinforced with 10 mm diameter bars at the rate of 200 mm center to center. Okay. So this is a one concrete slab whose thickness is given as 150 mm and reinforcement diameter of the bar is 10 mm thick and the spacing of the bar is 200 mm center to center, located at an effective depth of 125 mm. Effective depth of the slab is given as 125 mm. If M20 grade of concrete and Fe415 grade HOSD bars are used, then estimate the ultimate moment of resistance of the section. Okay, so this is one slab where the reinforcements are provided and you need to find the MR of the section. Okay, so what we will do, as the slab, that is, this is a simply supported slab, this slab can be served as a singly reinforced beam. Okay, so the way you have find the MR for a singly reinforced beam, the same way the same formulas will be used over here to calculate the MR of a singly simply supported slab. Okay, so only difference is in case of beam the width is fixed, but in case of slab the width will be considered for 1 meter and the MR of n also will be calculated for 1 meter width of the slab. Okay, even the area of steel, whatever the area of steel we will calculate, that will be also for 1 meter width of the slab. Okay, so let's solve this based on the steps. Say step 1, that is, we will write all the given data. So whatever the data they have given, let's see that thickness, that is the overall thickness. Okay, thickness capital T is equal to 150 mm, right? Effective depth small d is equal to 125 mm. Okay, so for M20 concrete we can write FCK is equal to 20 Newton per mm square. And for Fe415 steel, Fy will be equal to 415 Newton per mm square, isn't it? Along with that, for Fe415 steel, we can write the limiting depth of neutral axis ratio with the effective depth as 0.48, right? That also we can write. Along with that, they have given 10 mm Phi dia bar is used at the rate of 200 mm center to center, right? Therefore, we know AST will be equal to what? AST will be equal to B into area of 1 bar. So area of 1 bar, I am saying that A5 divided by spacing, right? This will be the area of steel in 1 meter. If I consider the B as 1 meter, then within the 1 meter, if area of 1 bar is A5 and spacing of the bar is say 200 mm, then you can find the area of steel, isn't it? This is the formula. So considering width of slab B is equal to 1 meter and that is equal to 1000 mm. Okay, the B we are considering 1000. So A5 is what? A5 is equal to area of 1 bar, that is pi by 4 into 10 square, right? That is the area of 1 bar and spacing is given as 200 mm center to center. So therefore AST will be equal to 1000 into pi by 4 into 10 square divided by spacing. So if you calculate the area of steel, you will get 393 mm square. 393 mm square of area of steel, and you can write over here in 1 or per meter width of the slab. Okay, this is not the total area because this is only the 1 meter width include this amount of area of steel. If you talk about the next meter, that amount. If you talk about the next meter, that amount of steel they have provided in this beam. Okay. Now, in this slab, we need to find out what type of slab it is, whether it is a balanced slab, whether it is a over reinforced slab, whether it is a under reinforced slab, isn't it? Because without that it will be very difficult to write the MR equation, isn't it? So let's find the XU, as we have already the XU max. So that is XU is what? XU is the actual depth of neutral axis, which will help us by upon comparing the XU and the XU max, we can find what type of section it is. Or we can compare XU by D with the XU max by D, isn't it? So let's go to the step 2, calculation of actual depth of ME, and that is XU. Okay, so we have the formula like the beam. You can write that XU by D is equal to 0.87 Fy AST by 0.36 FCK BD. Okay, this is the formula. So if you put 0.87, Fy is 415, AST is 393, and 0.36 into 20 into B is 1000. Very carefully you have to put the 1000, and D, which is directly given, the effective depth is 125 mm, 125. So you can find the value of XU by D. So your XU by D will be equal to, if you solve by your calc, you will get XU by D is 0.15157. Okay, so this is your XU by D. Now if you compare with the XU max by D here, this is your XU max by D. Now XU max by D is 0.48, XU by D is 0.157. That means XU by D is less than XU max by D. Then you can measure now, or you can identify what type of section it is. It is a under reinforced section, isn't it? So if I write the check for type of section in step 3, check for type of section, then as XU by D is less than XU max by D, so I can write, so it is an under reinforced section, right? It is an under reinforced section. Now it is confirmed, as it is under reinforced section, what will be the MR equation, right? That will be 0.87 Fy AST D into 1 minus AST Fy by BD FCK, right? That will be the MR equation, because that is under reinforced section. So let's write the step 4, calculation of MR, and that is your MU, right? So MR is equal to, MU is equal to 0.87 Fy AST D into 1 minus AST Fy by BD FCK, right? This is the formula for under reinforced section to find MR. So let's put the value 0.87, Fy is 415, AST is how much? AST is 393, D is 125 into 1 minus AST is 393, Fy is 415, B is 1000, and D is 125, FCK is 20. Okay, so if you solve this, your MU will be equal to 16.58 into 10 to the power 6 Newton mm. If you want to convert in kilonewton meter, just you need to remove the 10 to the power 6. So you can write 16.58 kilonewton meter, and this is your required MR of the given section. Okay, so you should not get worried whether it is a slab or whether it is a beam. The singly reinforced one-way slab or singly reinforced beam or one-way slab is same in the calculation part, okay, because slab is nothing but a beam having the lesser thickness, okay. So this is the very easiest way, stepwise procedure, where if you strictly follow this procedure, you can directly find the MR of the given section, okay.